사실은 Okay. This dang on. Hello, hello. I am. Oh, is my keyboard on? Oh yeah, it is. Okay. Howdy. Howdy. Been a little bit. I think a week was the last time I streamed, so it's been a little bit. I have not really been doing Rust stuff on the side. It's been more music stuff recently. So a lot of work has been gone into more of my music skills, so that way inevitably when I do make a synthesizer, I actually know how to play it, because it's one thing to make a synth, it's another thing to know how to use it. A classic example is of game reviewers who test play a new video game, or they don't know how to play it, or they're really bad at it. So they can't really give a good review because they're struggling on the first boss, you know, the first level of the Mario world. So, can I really play a synth that I make? Do I really know what I'm missing or not designing well if I can't even play it? Who knows? Who knows? But today we are going to probably do some Rust stuff, as the title says. Maybe some more looking into the alarm clock, because the alarm clock works. It's just I want to refactor it. And I think there's a maybe easier way, maybe not easier, but a cleaner way, because it looks pretty messy. And this could just be the core of Rust altogether that I am not using like well or efficiently. So I'm thinking maybe we look into that a bit. I kind of got my tablet out here because I remember doing a little bit of stuff off stream. Let me show this. Okay, hold on, a little bit of a extra thing there. Here we go. And then I do this. Okay, this is good enough right now. Yeah, I made this notepad, and on it, hold on, just trying to move this around. On it, oh wait, can I do that? No, I'm trying to figure out how do I scroll with this thing. Okay, that's to go up and down. I want to go right. Is there any trick to that? Not sure. Even with the mouse, I don't know how to do it. I mean, I can do this. Oh, zoom out. Yeah, I'll do that. Okay. Yeah, I was trying to figure out how to make this like state machine in Rust, and state machines in Rust. State machines and easy, they do not exist. These are not this is not an easy thing to implement Rust, which is kind of ridiculous. I either don't know how to do it, which I don't, or it's state machines are inherently not a thing that fits in the regular Rust paradigm or the Rust safety design pattern. Like, this usually requires some kind of global variable, like a global state, and this does not work so easily in Rust. So I was trying to make a state machine where I have a game that can only be in 4 states, really. It can only be a new game, or the game started and it's white's turn in chess, or the game started and it's black's turn in chess, or the game is over. Because those are honestly the only 4 states that the clocks will ever be in. This one you're configuring settings still. This one you're waiting for white to press its button and it starts counting down the timer. This one's the same but for black, and then this one is the timers stop but you're expecting a new game button. So like all of these states, kind of how I want the flow of a alarm. Oop, delayed too much. The flow of a chess timer to go. It's just not so easy in Rust. And it could be my lack of Googling too. So that's one thing. Go ahead and remove this. I might make a checklist with that, right? Checklist on things maybe I can achieve by the end of the stream. Let's see. So before we've done this, did I make it here? Nope, here. Or maybe I deleted it. Whatever. Just make yeah, sure. Here, let's make a new page. Checklist. Today's what, the 9th? Yep. The 9th. Checklist. Okay. So things to do. We want to figure out state machines. In Rust. Another thing I'd like to do is, well, I don't even know. Refactoring. Refactor to static or like module functions. So functions that handle our loop stuff instead of having everything inside of just one giant loop. You know, like our entire code base is basically just inside of a loop statement. But I really want this to be maybe like 2 lines in the loop. And then maybe some like async spawn of some tasks. Task 1, task 2. Because I learned today that when people are designing real-time operating system type things, that they generally have like a thread that is time safe and another one that is not as time safe. Does that make sense? Like an example that I was seeing with DSP, they may have 2 threads. They'll have thread 1 and 2. 1. Thread 2. But they only have one processor, so they can't be doing both of these at the same time. Instead, they're going to allocate thread 1 to be real time and this one to be non-real time. So in the DSP case or the audio case, this thread 1 was tasked with like write audio, right? Or like play audio, rather. Play audio. So its whole thing was just sending audio out of the device. No like effects, no clever stuff. Just an easy play audio, because you don't want this to be interrupted, because this is time critical. If it got interrupted, you'll hear glitches, and with audio, that's not good. We don't want a glitch. And then thread 2 would be like, I don't know, chorus settings, right? Knob settings, LEDs if there are any, USB protocol, probably in a different one, but let's just actually chorus settings like effects, or in other words, they would say DSP here, but these are separate. And this executes always at like, I don't know, every 10 milliseconds, let's say, or not even that. You would need to do it like every millisecond. Like your audio, you're playing audio every millisecond, or you're preparing the next bit of audio every 1 millisecond. And Like, so let's say this is 1 millisecond long, right? This is 1 millisecond, this is 2 millisecond, and the task actually just takes maybe like 100 microseconds. So 1,000 microseconds would be 1 millisecond. Your real-time thread 1 only takes this much time. That means you have all of this space here to do this stuff, and they maybe design it like that. So maybe I do it that way. It's just I haven't gotten there yet. So this checklist kind of got a little bit derailed, but the point of it is more just like Rust isms that I'm trying to figure out. That's the core of it. Rust isms. Okay. So I get settled. Open up my project from the other day. And also turn this on. You see? This counts down. Not sure if this was in the last stream or not, or if I did this off stream, but this works fully. I think it was on the last stream, but yeah, that's a working counter. Another thing that I kind of need to do is I've decided that I'm maybe not going to use, I'll slide this over. I'm maybe not going to use this chip for this project because this chip might be very overkill. This chip is for ultra low power stuff, but it doesn't need to be one that has a bunch of other features. STM did just come out with another device. Not device, but another chipset. Another chipset called the U0, which is even more low power, but it is on the core that makes it secure because it has memory safety in it, which is probably a good thing. And well, yeah, it's super low power. It's half low powerness according to what they're saying. And so they doubled how efficient it is compared to some other chip. I don't even know which one they're comparing it to. That could have been their least. They might have done some marketing shenanigans where they compared it to the most powerful chip. You know, half as powerful as that. Okay, well that is a true statement, but that could be misleading. Either way, it is still an improvement, and it's just new. You know, I was thinking it was gonna be cheap. It's not gonna be as cheap as like an I think it's called an Tiny. AVR makes or Mega makes. But I do like the STM ecosystem. I have faith in it more. Professionally, so I'll just keep that. So yeah, this may change, but the glory of the Rust framework that I designed everything in is that it all should just transfer over. I changed the compiler perhaps, but I'm not using any functions that utilize the compiler's special assembly calls. Like I'm not using any of the DSP stuff because this is not a DSP project. This one at least is not a DSP project. So I'm kind of like simplifying it using a different STM chip that's meant for low power stuff. So that way, if I do design a PCB, which I do plan on probably, I can use something that's not going to be super powerful and a smaller footprint than what this is. Like this is the largest package size right here, this black box. This is the largest package size for the U5. The one that I would be getting is probably more the size of this, if not smaller. This black box where my finger is. But, yeah. So, let's see where I left the code, what state it was left in. So I definitely started this game states idea that I was doing on the whiteboard. I made this enumeration. This was an idea that I had on how to implement game states because this is what I'm used to in C. You make a enumeration that has a bunch of constants. So you have some keywords like new game, white turn, black turn, game over, which equate to, yeah, 0, as you see here, 0, 1, 2, 3. So if I ever use this term, new game, I was thinking, okay, if I use this new game anywhere, it actually means 0. And at compile time, it replaces new game with 0. However, Rustisms, they weren't happy with that. I go to compile it and it gives me this error. Let's see if I can do it. Cargo make, or no, cargo build. It's gonna yell at me. It doesn't like me. Okay, it said, where is it? It said, well, this is funny. Perhaps my memory is going bad because it compiled and there's no errors about it. I don't know what to think about that. In fact, I'm quite surprised. Is this working correctly? Did I not actually do this comparison? I think so. Yeah, okay, hold on. This doesn't actually do anything. So I have this counter task that I was testing out, seeing if I could make it. I made it. It's a task that I was going to say handles just the counting. You know, this handles just this counting. Just the counting of the clocks. Because there's 2 different clocks, right? And it needs to count from each one, but they don't actually need to be their like own separate unique function call or like function definition. Like, right in this super loop, I have this whole dedicated section to dealing with the counting just for the black timer, and I have a totally separate one just for the white timer. These look almost identical. This block of code and this block of code, literally identical, just a different of word, right? It's not until the end that I actually do something with it. But this, if I know anything about programming, this usually can be refactored away into its own separate function. So you could just be like, yep, white, or, you know, counter, and then white. You pass in white. Some variable named white. Same thing with the black. You'd have a black counter and a white counter. It'd just be back and forth. But we had to figure out what that is in Rust. It's not super straightforward. So I'm going to be talking a little bit less because I have to put in my thinking cap. Got to think solution for this dilemma. Because my intuition is not how you do it in Rust. We got this whole switch case thing going on here with this match keyword, and the cases on what we're trying to see this variable equating to. Ideally, it was going to be a case for new game, right? I'd put new game here and then do something, and then I would do another one for, you know, like for white turn. Like I'd want it to do something. Info. White turn. That kind of thing. But this was the original error I was talking about, where it says mismatch types. Expected unsigned byte or U8. But instead it found this enumeration, which is up here that I created. Rust doesn't know automatically that this enumeration, that these values here are U8s. So, I mean, it shouldn't be like if I was doing this correctly, I would imagine I could have just done something like this. Okay. Something like U8, but nope. Can't typecast there. That's not how it works. It needs to be done a different way. So we reference our good friend Google. See if there's any striking examples. Anything at all. The unfortunate part is I was looking at this a long time ago, so I don't really remember what in the world this page is about. So I might just research for something like this. If we look up like an example of, I don't know, maybe a Rust embedded state machine, perchance. State machine peripherals as state machines. Hold on. Wait a minute. You're telling me in the Rust book they talk about this? The peripheral of a microcontroller can be thought of as a state machine. For example, the configuration of a simple GPIO pin could be represented as the following tree of states. These are states. Those are states. Starts in this mode. Move to the input high resistance mode. Okay, hold on. Hold the phone. I don't see these states. Typically, the states listed above are set by writing values to the given registers mapped to GPIO peripherals. Talk about it. So they have a function called enable. They have a function called direction. Function input mode, function output mode, function input status. Okay, but how is this a state machine? That I'm not seeing. I'm not seeing the state machine here. I'm seeing a function attached to a struct. Multiple functions attached to a struct. Yeah. Type state, what is this? The concept of type states describe the encoding of information about the current state of an object into the type of that object. Although this can sound a little arcane, if you have used builder pattern in Rust, you have already started using type state programming. Okay, we have struct here. What? What is this referring to? Types? Is this just talking about how you create this variable you pass in here? Double A, new, yeah, I'm not too sure about that. What about all these other pages? Design contracts. Let's try another imaginary GPIO register. Design contracts. If we instead check the state before using the underlying hardware, enforcing our design contracts at runtime, we might write code that looks like this. This is the same. We create a function. This function is modifying a register. And it's just the same. Set direction. This one is you're checking if enable bit is clear, then it's doing something. This one you are setting a bit. You exit with OK. How about any of these? I mean, there's just more error checking, it looks like. What if we keep going down? What if instead we use Rust's type system to enforce the state transition rules? Ooh. Ooh, this is neat. You have a peripheral? Gets this. Peripheral can be enabled as a direction, as a mode. You can also pass in a generic for enable, direction, and mode. So they made these structs globally, these names. These functions may be used on any GPIO pin. So implement enable, direction, input mode. It's a config. You're making a config. And there's also a function into disabled, into enabled input, into enabled output. As in you're transitioning into that. Like a state machine is my guess. Config starts off as disabled, don't care, don't care. Or no, it returns the config. This is the function. The function takes no arguments. It starts off by modifying, and then you're writing to the enable register to disable it. And then you create a struct, an instance of this GPIO config, but you attach peripheral to it. You then pass in disabled to the enabled pin. You pass in the don't care to direction, don't care to mode. But why would that do anything? Oh, because you return it? You return it. This gets returned. I see. This gets returned. Huh. Yeah, this is them using that code. Well, I definitely can make a more complex code base, but you know, it could work. Zero cost abstraction. Yeah, I'm not gonna read that. I see, you make some code, but the compiler is smart and designs it away. What about in here? Anything wild in this design pattern area? All re-exports to the register access crate. All traits, predictability, GPIO. This is all just nonsense. That's not what I'm looking for right now. What do we got here? Compile time code selection. What are you doing with this macro? There's a tag, I guess. You're just saying you include this based off the feature you pass in. Okay, yeah, I mean, that's cool. That's cool. What was this? Oh, I got a volatile access in C. Individual variables may be marked volatile, indicating to the compiler that the value in the variable may change between accesses. Volatile variables are commonly used in an embedded context for memory mapped registers. In Rust, instead of making a variable as volatile, it uses specific methods to perform volatile access. So read volatile, write volatile. These methods take a constant t or a mutable t, so a raw pointer, to perform a volatile read or write. Wow, that's very different because this was not anywhere in any example ever. Why is this now coming to my attention? This is interesting. So you got your driver here. Infinite loop. Ooh, it's unsafe access. Maybe that's why. It's unsafe. You get a pointer, you're reading volatile. You're passing in a borrowed value that is a static, so it's global as well. It's static. Read here. Because you say unsafe, that's what allows us to work. So this is just C code, just writing C code. Yeah, I mean, this is forcing C a little bit. Oh, that's how you do that. Okay, hold on. What else? What else? Unsorted topics. Optimization. And manslide. Yeah, it's not quite what I'm looking for. Concurrencies or anything here? No concurrency. global mutable data. Unlike non-embedded Rust, we will not usually have the luxury of creating heap allocations and passing references to that data into a newly created thread. Instead, our interrupt handlers might be called at any time and must know how to access whatever shared memory we are using. At the lowest level, this means we must have statically allocated mutable memory, which both the interrupt handler and the main code can refer to. Okay, statically allocate. So this is the C way. What are they talking about? Oh, well, this paragraph talking about race conditions with static mute, so you gotta be careful. Which is why you'd use volatile, but kind of example. Okay, they're showing how that race condition could be a problem. Okay, yeah, critical sections. That's how they solve it. They solve it with critical sections, and maybe that's just what I need to do. Maybe I just need to make a critical section. What do we got here? Simple approach using critical sections, a context where interrupts are disabled, I mean. Wrapping the access at this. What is this? Wrapping the access to counter and main in a critical section. We can be sure the timer interrupt will not fire until finished incrementing counter. I think I may go in this direction. I need to see if it works with Embassy and how I've laid out the code, but I want to try this out because we got this interrupt here, and I would love to have an interrupt like this. Just comes out of nowhere. Unfortunately, abstracted it away in this example where they said, yeah, let's set up this timer here. Let's just, you know, create this all, because it's a generic example. It makes sense. They set up this timer. Like, this was not easy to figure out. And it's just, I don't want asynchronous programming if I can help it. I think async is like overkill for what I'm doing. It might be necessary with DSP, but it's probably not necessary for this. What's this? Atomic axis. So this was the direction I was using. This is what they have here. Atomic use size. Counter. Fetch add to atomically add 1 to the counter. Yeah, this is the current way I'm doing it, because it has this ordering. Use store to write 0 directly to counter. Store is the way to do it. Interesting. This is neat. This is neat to me. Abstractions, send, and sync. They require unsafe blocks, which may be very carefully checked and not ergonomic. Surely we can do better. Oh, they're saying all these are using unsafe? This isn't using unsafe. There's nothing unsafe about this because you're doing atomic accesses. This is the way I have it. We may come back to it. This seems more chaotic. There's no way that's the like easiest way about it. So this one, we abstract our counter into a safe interface which can be safely used anywhere else in the code. So they created this struct that has this unsafe cell, which is, so the struct is a wrap around this cell, which is built with immunity, or yeah, mutability. Oh, okay, mutability is not something you build with. You just make it mutable or not. CS counter init. So initialize instead of this data type of the struct, and you're calling the new function for the struct. So you're making a new unsafe cell. This is unsafe at its core. It even says it right there, right? They also made some new things, new functions that they defined here. This one is a critical section. This one's incrementing an unsafe block. I just don't think this is good. I think that this one It's messy. I'm gonna scroll past it. Mutex is a very common way. You know, lock it up. It's still the idea is you're putting it around a critical section. But when I see mutex, I mean, it's using this cell. This cell, the core library. That I don't know. We're now using cell, which along its sibling, ref cell, is used to provide safe interior mutability. We've already seen unsafe cell, which is the bottom layer of inferior mutability in Rust. It allows you to obtain multiple mutable references to this value, but only with unsafe code. A cell is like an unsafe cell, but it provides a safe interface. Oh, wonderful. Music to my ears. Is there a problem though? It only permits taking a copy of the current value or replacing it, not taking a reference. Since it's not sync, it cannot be shared between threads. We're not using threads, but we are using async tasks, so I might treat it the same. I don't know about that. Okay. These constraints means, hey, welcome Naka, welcome. Are you getting into Rust? I mean, you got time now. This is the time. It's Rust time. I don't know if you've heard about my Rust endeavors, but it's Rust time. Hell yeah. Leak code. You could do those. Look, you could go to leak code right now. Leak code, Rust. It's a thing, I think. I mean, maybe. Oh, they changed this website. What the heck? This looks way different now. You can tell it's been a bit. You have to make an account? Oh my. You gotta make an account to use this now? That's, oh my god. Can't go to this playground. Okay, maybe this is it. Oh yeah, here we go. Where is it at? Where is it? There it is. Boom. Hello world. Hello world. I know I can't see it on the stream. Oh. But do some? I don't remember any of my leak code. My leak code data structures. I forgot it all. But it's okay. Okay. I'll get back to it at some point. Twosome. I'm pretty sure that's like the easiest one, though. Twosome is you're combining the sum of two linked lists or something like that. Let's see. I'll open it up. Twosome. Given an array of... Get that C++ out of here. Rust. Okay. Now we gotta zoom this out a little bit. Given an array... Oh, I see. You're trying to see if the two values add up to... No, I should just read it. Given an array of integer nums and the integer target, return indices of the two numbers that add up to the target. I definitely remember doing this. I did this for sure. Just not in Rust. I did in C++ back then, but we all done that. Rust. The problem is all of my experience with Rust has not been using the standard library. Vector uses the heap, which is not in the standard library, just like you would in C++, right? There's a vector too, yeah. So it might functionally look kind of similar. All I know is if I was doing it in C, ooh. Actually, I might have done it in, no, there's a chance I did it in C back then, but it's just so much easier when you got this built-in standard library, like swap, or not swap, but like hash mapping, you know, binary search tree. Like, I don't fully remember, but I remember there's just built-in functions into these data types like vector. Let's see what how Python would do it. Python LP, is that how you doing it? I heard there's like a meta, right? You use Python, there's some like cheeky little tricks that people use. Autocomplete, that's new. Oh, it's autocomplete if you're typing. I was like, autocomplete the problem? What? No, I'm just kidding. Python's nice. Are you only applying for Python jobs nowadays, or just backend Python, or what? I'm just looking at this. I don't know what Racket is. Isn't Pandas a framework? Oh no, it's a language. Any backend, any at all. Kotlin. Oh, okay. So you're using the framework. Is it? Oh, it's in here. The Java-based extension language from Google. I remember using that for a very simple Android app. Very, it was like a tip counter. Calculate your tip at a restaurant. I was following a tutorial to the T. But yeah, I'm not doing this right now. In fact, I hope to never apply for a place that requires me to do that. That's right. So far, not a single position I've applied to needed that. It just made me more comfortable with the standard library of the language, which was kind of fun. But it's not what they used to measure if they wanted you on the team or not. That is a very just software position thing to do, not embedded. Okay, where was I here? Just showing how they used mutexes to access variables, or no, peripherals. So what do they have here? They have an interrupt. They have a mutex here. Well, this might just be how you use interrupts actually with this particular library. Because I'm not seeing mutex except for right here. Okay, this is the mutex. So they made a static mutex. This is allocating that mutex. This is passing in the type of template to make the mutex around. Then do they use this anywhere? My GPIO? Down here. So around the interrupt, they borrow the mutex and they assign it to this. So now, so they're mutexing the access to this variable wherever they initialized it. Maybe this is just yeah, this might just be it. They are borrowing the mutex in the interrupt, so that way nothing could possibly take it. But the thing is, oh, here too. Does interrupt free make it so you don't, like, you turn off the interrupt? Store the GPIO A in the mutex, moving it. This is too much like real engineering for you? Okay. As in like your job from the past, or as in like too much like hardware, I guess. I don't know. Oh, because I mean, I guess if you're doing leak code, yeah, that don't always look like. If you're doing leak code, it don't look like real engineering. I could see that. Looking through this, I was tipped off about this Arctic, but I didn't actually see if there's any benefit to using it. So let's talk about a real-time OS, and then multiple cores. All the examples using critical section. Assume the only other execution thread is the interrupt thread, but on a multi. Yeah, people come into the stream to be stressed about work or real engineering. YouTube too, yeah, I know. You can go there for no ads. So that's honestly the more premier viewing experience. I definitely recommend the YouTube. But You may not get the cool chat emotes. You don't get my emotes. The ones that I made. Fortunately. Yeah, I really just... This didn't really help me, if I'm being honest. This did not help me. Concurrency. It's a little bit tough, you know. It's relearning how to ride a bike. You have to do things differently for this to work. It's allocating stuff. It's like making my brain be like, oh. Because I just did this a week ago and I forgot it. Alright. Like, is this implementation even the way to do it? That I'm not so sure about. It kind of seems like it's not. If it makes sense. Let me look at Arctic. Because I think it doesn't quite work the same way that Embassy is. Embassy can support Arctic. Let's see here. Arctic and RTOS. Arctic developers' point of view. Arctic is a hardware accelerated RTOS that utilizes the hardware such as the interrupts and also interrupts. Perform scheduling rather than the more classical software kernel. Alright. If I don't use the executor, then I can use this. So I'm pretty sure I can use this. Now, how do we get into this? That's the question. How do we get into this? Because if we use this, well, then we don't really have to learn a new framework again. Let's look at a minimal app before reading all this. Okay, so you're getting rid of some of the compilers built-in flags, or not flags, but features that it looks through when it's analyzing your code. Panic handler, okay, that's the same, nothing different there. They import the Arctic framework. They have to initialize it like this. Not sure why they need a device. Maybe that's to determine the compiler. This is the overall app. Initialize, local, shared. What is this? These memories? Local memory, shared memory? Let's see. Arctic is designed with the resource efficiency in mind. Arctic itself does not rely on any dynamic memory allocation. That makes sense because you don't do that embedded. Thus, RAM requirement is dependent only on the application. The flash memory footprint is below 1 kilobytes, including the interrupt vector table. That's pretty small. So the entire Arctic application, less than 1 kilobyte. They also compiled probably in a special way to make it under 1 kilobyte. It's only 924 bytes. Nice. So, Arctic by example, that's what we're in. Starting a new project, this, you'd run that app. Okay, yeah, sure. Walking you through examples of increasing complexity. We started on QEMU to emulate the processor. Makes sense. They're building it. Is this the output? This is the output of some example. Okay. All Arctic applications use the app attribute. This attribute only applies to a mod item containing the Arctic application. The app attribute has a mandatory device argument that takes the path as a value. This must be a full path pointing to the pack. Okay, this is where I need to see how they do it with Embassy, because if it's not, if this is, if I don't pass it to here is not going to know how to use Embassy. Because they're used to this SVD2 Rust. This is the more popular way for bare metal programmers that are just doing everything from scratch, because this is just like a bunch of defines and constants of the entire hardware. All the registers and stuff are in here. But for some reason the community is like, yeah, I'm not gonna make it for this chip, I'm gonna make it for everything else but this chip. And in fact, we're gonna use the Embassy one instead. That really threw a wrench in my design plan. I'm just complaining about the first world problems of coding using open source tools. So the Arctic app is an executable system made for single core applications. All right, fine. Declaring a set of local and shared resources operated by a set of init, idle, hardware, and software tasks. Hardware. We like hardware. Init runs. Sorry. Just felt the need to have to hit this button. That was counting again. Init runs before any task, returns the local and shared resources. Tasks run preemptively based on their associated static priority. Hardware tasks are bound to underlying hardware interrupts. Yes. Yes. We love that. So this is just ISRs. This is just ISR. That's what I wanted. That's exactly what I wanted. Software tasks are scheduled by a set of async executes. That's not what I want. But okay. Idle has the lowest priority and can be used for background work or to put the system to sleep until woken up. Okay, so that's good. It has built-in sleep time. That's really good. Did I? Okay, never mind. Compile time. Task resource model is analyzed under the stack resource policy and executable code generated with the following outstanding properties. Guaranteed race-free resource access. Okay. Deadlock-free execution on a single shared stack. Wow. It can guarantee this? Hardware task scheduling is performed directly by the hardware. Okay. That's good. Because Embassy does not do that. It tries to do something clever or uses a software-defined interrupt, but that's, again, software defined, not hardware. Software task scheduling is performed by the auto-generated async executors tailored to the application. Overall, the generated code infers no additional overhead in comparison to a handwritten implementation. Thus, in Rust terms, Arctic offers a zero-cost abstraction to concurrency. Priorities in Arctic are specified using priority n, and it's passed to the hashtag task attribute. All tasks can have a priority. If the priority of a task is not specified, it is set to the default value of 0 or zip, nada, zoop. So here's an example. They will hopefully explain this going on later. Arctic app. So declaring an app for this device. Dispatchers, I'm guessing, is hardware interrupts. So they got UART0 and UART1. They're importing this semi-hosting thing for debug and print statements. Shared memory, local memory. So here's some local, it's a local struct they defined in it. Hashtag init cannot access locals from the local structs as they are initialized here. Local to foo. They are only initialized in the function, the scope. But shared would mean every single task can access it. That is what I'm assuming. What do we got here? Initialization function. Foo. Var. So they just spawn some tasks. They spawn some tasks. Software tasks? I don't know. They just say tasks. They're probably later. Yep, bar. Foods or software. Oh. Software tasks. And then, what is this? This is what gets returned. Shared and local. So you initialize shared and local here. Whoa. So the initialization, you're okay, that's a different way of approaching it. This is just initialization. Data. You create some, data types, but you're not putting any data until you declare it here. And this is just how it gets made. Local to idle can only be accessed from this context. Idle. Local equals local to idle. Not sure what local to idle, if that's attached to anything, or if that's a keyword. I'd have to read more. It looks like it's a keyword. It's idle. You can pass in a context to idle and it returns nothing. Local to idle is the context local to idle. So now you have this local to idle, whatever that means, and you're adding 1 to it, the pointer. Print this out to the debug and also debug the exit success. And then you're looping in a no operation, assembly no operation, forever. Until something else interrupts this. Something else interrupts this. Then you exit out of that until that task is done and you probably go back into idle. That's my assumption. Local to foo can only be accessed from this context. So syntactically, this looks like a lot. This looks like a mess, kind of. It's not very easy to read like Python is. That's okay. As long as I can figure it out, then we're good. But if I can't figure it out, well, shoot, we are screwed. That's the case. Local to foo. So the same kind of thing. You're getting the context and you're creating this variable. Or this local variable that you somehow are mutilating. Or you're mutating. Which kind of blows my mind. Because you're not saying let mute, you're just saying let, and then you use this dereferencer. Like it's a pointer. Is this a pointer? Well, no, this is a context. I guess you can access contexts that way? Never gets... Yeah, it's part of the library. Huh. Shows how much I know about it. This looks like it's the same, just you're in the bar situation. Hardware tasks. Okay, this is what I like to see. Arctic is using a hardware task. Hardware interrupt controller to schedule and start execution of tasks. All tasks except preint run as interrupt handlers. So they're also software defined interrupts. Ooh. To bind a task to an interrupt, use hashtag task attribute arguments binds equals interrupt name. And then this task then becomes the interrupt handler for the hardware interrupt vector. All tasks bound to explicit interrupt are called hardware tasks since they start execution in reaction to a hardware event. I hope this isn't what I'm thinking it is and misleading. Specifying a non-existing interrupt name will cause a compilation error. The interrupt names are commonly defined in pack or HAL. Okay, that's good. Any available interrupt vector should work. Specific devices may bind specific interrupt priorities to specific interrupt vectors outside user control. See example for interrupt soft device. Let me reread that. Any available interrupt vector should work. Huge. Huge. Specific devices may bind specific interrupt priorities to specific interrupt vectors outside user control. They would do it already for me. Some things, oh, it does make sense. The way it's defined, it already has priorities between interrupts. Like that's just the hardware interrupt vector already does that. That makes sense. That's a nothing burger. Beware of using interrupt vectors that are used internally by hardware features. Arctic is unaware of such hardware specific details. Okay. Okay. That's I need to see example because this is leading in the direction of what Embassy was doing, and that's not what I want. The example below demonstrates the use of task binds and the interrupt name attribute to declare a hardware task bound to an interrupt handler. For example, a asset interrupts for this exact chip or this device. Oh wow, okay. Equivalent to NVIC pen. Arctic pen. Pens the UART0 interrupt, but its handler won't run until after init runs because interrupts are disabled. Pens? Maybe it gets turned on by some point. This is in the init. You're initializing this tuple of memory, shared in local memory. Declaring that this interrupt for UART0 will be pending. In the idle case, you penned the UART8. So does that mean you're disabling the interrupt? Is that more of it? And this is your new operation, and then exit successful. You enter this for some reason. Binds UART0 local times 32. UART0. This is the interrupt handler. Binds UART0. This is coming from the library. UART0, UART0. This is the local memory. And you are saying, hey, add one, I guess, to this local mutable static too. Static mutable variable. Okay. This is just always how you access it. You're printing it out. You're doing some stuff to it. So this looks right. I looked to the side and my eyes caught this page right here that says Arctic and Embassy. Let's see. Embassy provides both HAL, executor runtime with the HAL, while Arctic aims to provide only the executor framework. That is actually my gripe with Embassy. So if this replaces the executor, but I can still use the HAL for Embassy, we're golden. Let's see. On the other hand, Arctic provides a framework in the form of Arctic, and the user is responsible for providing a pack and HAL implementation, generally from this STM32-RS project. But if you're using Embassy STM32 HAL, it's not how you do it. Additionally, Arctic aims to provide exclusive access to resources on as low a level as possible, ideally guarded by some form of hardware protection. This allows for access to hardware while not necessarily requiring locking mechanisms on the software level. Access to hardware while not requiring locking mechanisms. Right? Mixing use of Embassy and Arctic. Since most Embassy and Arctic libraries are runtime agnostic, many details from one project can be used by another. For example, using Arctic monotonics in an Embassy executor powered project works, and using Embassy Sync through Arctic, though Arctic Sync is recommended, in an Arctic project works. Go to this examples page. Examples. They used it on Teensy. That's fun. What's the Teensy one look like? Arduino? No Arduino. They made their own BSP for it. Good for them. Good for them. Asynchronous task. Yucky. I'm not gonna read that. Here's a STM. This one's a Blinky. This is an interrupt, real-time clock interrupt. Love to see this one. This is a long page. Wow. Okay, where are we at? So, they define their device. They defined their pack. Oh, this is how you're doing it. So if you have an MSC pack, you can just do it through here. Okay. Peripherals equal to true. Not sure what that's about. Have to read it. This is part of the HAL framework for STM32F4. They declared some shared resources between tasks and local resources to specific tasks that can't be shared. So they have a local, they have the button, they have the LED, they have the timer, a timer, not the timer, a timer. Initialization creates a device package. Configure and obtain handle for delay abstraction. Remote RCC structure to HAL to be able to configure clocks. This is boilerplate for that HAL. Boilerplate. Arctic. Alright, this is real-time clock. You're setting a real-time clock registers. Enable wake up for the real-time clock. And listen. So this is part of the HAL. This is with the timer. You want a delay of this. Configure LED pin as a push-pull output and obtain handle on the black pill. There's this onboard LED. So you get the GPIOC. You then configure it with this HAL function into push-pull. You say that's what the LED is going to be equal to. You then do the same with A. This is going to be your button. You then do the system config to configure interrupts. You have this button. You want it to be interrupt source. You define how it interrupts. Trigger on edge. These are all HAL functions, but initialize the HAL interrupts there. And then you initialize the data. You make just these variables, button, LED, delay, but you want the shared LA value to be 2000 unsigned 32 size, and then the real-time clock that you created up here, and now this is now shareable. Ooh, makes it a lot easier. I feel like, right? Real-time clock, boom, right there, easy. Real-time clock. It's shared. Play value, shared for some reason. Okay. Local LED and delay. So you're using a local version of the LED and delay, but it gets deallocated when you're done with this idle function. I think that's the key of this local. LED, delay, sure. They didn't do the asterisks on this, so I guess you don't need it. Yeah, alright. LED just in the context of here. You have a delay. Delay is global, I thought, though. No, I just now realized. LED delays. Oh, delay val is global. Sorry, delay is not. So delay is just the peripheral itself. You're accessing it this once. But you do get this shared delay value and you lock it so that way it can be accessed by something else. That's a paradigm. You're going to use a constructor del or delay. Obtain obtain the delay and have the timer run for that. Turn off the LED, then do it again. You loop forever and ever and ever, unless probably this interrupt handler occurs. In which case you have an external interrupt, which is based off of a button. You press a button and you jump out of this and go into this. So now they did some logic where they passed in the del, dereferenced it, that del subtracted by 100, put it in this temporary value. This temporary value, if it's less than 200, then make it 2000. And then you return that delayed value. So this is you putting it back into the delay value. Now it's just in there, you're no longer locking it. You got a lock over here for the real-time clock. So nothing else could possibly access it. This is a lot of stuff to be doing in an interrupt handler, by the way. I feel like my interrupt handlers don't have this much stuff going on, but okay. Get the time. Get the time. You print out the debug. Disable wake up. It's a function. So this is just a critical section. You're locking it. Clear interrupt pending bit. This is you clearing the bit. Most interrupts have some kind of flag. You clear when you're done using it. Then you exit out and you just go back to wherever you're working on. Here's a software-defined interrupt, I think. Never mind. Fine says RTC wake up. This is hardware-defined as well. So, uh-oh, you got to interrupt. Look how extreme this warning is. You enter here. You make another critical section. You say, okay, what's our current time? You clear the interrupt, and then you write out your current time, and then you're done. You go back to your idle, and then you start blinking your LED again until it's time again. This is a great example. This is a really good example. Is Arctic 2 in here? It better not be a different repo. Okay, good. Still just this repo. So, how... I'm gonna guess there's less stars on this, but I'll look real quick. Embassy GitHub. So it was 1.6k stars on the other one, 4.3k. This is used more. That makes sense. There's a lot more in this. Loads more. I'm not a fan of this. How this is laid out, I'm just not a fan of. Interrupts aren't making sense to me on how to use it in Embassy. And maybe that's just my own misunderstanding of it, but I'm not seeing the pathway forward with Embassy outside of their pack. So let me do this then. Embassy Arctic. Can anyone give some insight into Arctic 2.0 versus Embassy? In my understanding, what separates these frameworks from another was mainly the async support, which Arctic now also has. Which one would you pick for a kind of project now? There's this official explanation. Sadly, I've never tried Arctic, so I can't say much about it. Okay, well then your opinion is not super valid. Since I've never tried developing on STM families, Although they sound awesome. Okay, anyways. I read in an article that they schedule things differently. So I think Arctic has lower overheads and MSC is always async. I wrote that post prior to Arctic 2.0. It's describing behavior Arctic 1.0. I'm not familiar with 2.0. Okay. Who's James Munn? He's from Founds Round Guys website. Co-host. Is this a Patreon or something? Huh. I don't know. I don't know. It's just text. Wall of text. Menu demonstration? Is it ASCII menu in Rust? Huh. Okay, well that's something else. Was quite excited until I found that 2.0 requires nightly. Wah, wah. The improvements look great, but I'm not willing to live with nightly Rust to get them. I'm afraid. I understand the motivation, and I think Arctic is a great project, but I'm happy enough with 1.0. It looks like it only relies on type alias implement trait, which at least is nearing stabilization. It might already be stabilized by now. I'll definitely check in later after that. Like I said, I used Arctic and really liked it. What was this? Nice, but I wish there was some 10,000 feet overview of what the major changes are. I use Arctic regularly, but it's hard to find any executive summaries of what design changes are made. For instance, why are resources split into local and shared between 1.0 and 1.5? What's new in 2.0? I'm guessing it may be a more async feature. If so, what are the reasons behind it? Blah, 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 blah. That page is, yeah. What about this? Proof of concept, Arctic plus embassy. Ooh. 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 Okay. Hopefully it's not using the embassy executor and... It's not. It's not. Okay. Are they using interrupts? They're not using interrupts. Using soft device. They're not using interrupts. Ugh. Man. Embassy executor global? What? Oh, man. Forever new? Is that because you need this to run the soft device stuff? You have an await? You have a Bluetooth task that you await? Advertise, that makes sense. Here's your main thing. You have init, context. You have the idle function. This config is pretty typical for the library, embassy library. Soft device enable. Executor. Okay, this is new. This is new. So you're still using the executor or the executor. You just are now calling it manually because your entry point is from Arctic. That makes sense. You would enter through Arctic and call embassy executor, whereas before you go straight to the executor. So the executor, they want to run embassy task, software task, Bluetooth task. These are all software tasks. So because I don't think you can do hardware tasks with embassy. Software task again. What the heck? Extern C function Swift. This looks like the name you'd see of a interrupt. Clock. Out of these devices, none of those are interrupts. Just read through this. Yeah, I mean, it's It's not quite the same I'm looking for. I wonder if they have another example. They only have gists? Is there no... Oh, they only made gists. Oh, man. Dang. Okay, what else? Are we RTOS yet? Wonder what this one's talking about. I visited this guy's blog before. This one's talking about interrupts. What kind of interrupt is he using? Let's look at the main code. The main code. Interrupt. This is that. What the heck? Why am I blanking on the word? IRQ? Is that normally what it's called? Gosh darn. Yeah, your interrupt handler. ISR, I feel like is, yeah, interrupt status register. ISR. Something like that. Like I'm used to that. You have this await function. You have this await function. So you write and then you wait for it to finish. So you initialize the interrupt up here. IRQ used any? Oh, it's passed into here. I see. So this object knows it can spawn its own interrupt. So it's like abstracting away interrupt handler. Damn. Not what I want. What's this? Feature meeting action points. This was made in April 3rd, 2024. That is not that long ago. Why? Why is this a future meeting? Why is this not current? Why is this not past? Gosh darn it. Arctic meeting. Future meeting. Something like compared to Arctic version 1 includes async while retaining. Compared to Embassy allows you to use async tasks and drivers. Also offering blah 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 blah. Framing expectation management. What is this page? I've been doing it since here. Triage, bugs in the wild. What is this page for? This is for Arctic based stuff. Okay. HackMD. Oh, of course. Well, I think I can get away with it. I just need to see, I guess, the pack. What do we have here? Using Cortex M Arctic. I'm looking for Major League Rugby's Arctic. That's new. MSC crates released and Rust stable support. Oh, these are all released. Major milestone with contribution from a lot of people. Something for everyone. A common source of confusion is that you have to buy into the entire ecosystem to use the HAL. However, the MSC HAL crate supports both blocking and async operation in most cases. I don't want blocking. Okay. You can use them without any runtime or using any or another runtime, such as Arctic. This way, there should be very few cases where you cannot use Embassy one way or another. The HAL implements the traits from here. Talking about each of the categories. All right, well, this is fun. This is the only blog post. This is the only blog post out of it all. Oh no. Let's go to documentation for Arctic again. And see what the device list is or what that's about. Because that's how we're going to use this. Let's see, migrating from one to another. Instead of spawn after and spawn at, you can now use async functions. Delay until divided by that. Software tasks must be async functions now. Makes sense. Not returning from a task is allowed so long as there's an await in the task. Using the sync to await access to a resource. Channel community. Okay, yep. Under the hood, this is concurrency. Oh, hold on. Okay, we have that processor. It's currently target all devices. The absence of the base priority mask register, which lends itself exceptionally well to hardware priority ceiling lists, ceiling support, Arctic. Well, it's not relevant to ours, I think, is what that graph said. Priority ceiling's there, so we're fine. Resources? Multi-lock? Lock free access? You can do that. Critical section is not required to access a shared resource. That's only accessed by tasks running at the same priority. Not required by resources that have them running at the same priority, because you can't preempt it probably. In this case, you can opt out of the lock API by adding lock free. So let's look at an example. They have this device. They have two tasks. Because they don't define it, they don't need to. These have the same priority, so one's not going to preempt the other. And then you can just go to this context and boom. Okay, I like that a lot. Really do. Maybe I just... Maybe I go and find an example here. And they like copy this. Memory could... Okay, that could get a little wonky. So this is the pack. Peripherals. I wish they explained this. There's got to be an API page. Channel based. No, that's something totally different. Go back to here. All devices are fully supported. API reference. Community provided examples repos is something different. This is something different. But this is using 1 or 0.5. This is examples. Teensy 4. You know, it kind of makes sense that the Teensy would be using this because the Teensy's application, it runs really, really fast. So if you're making music things that need a fast processor, this is a good popular processor for that. And then you would probably do real-time tasks anyways with it, so that also makes sense that they would prioritize that chip and make it its own project. Maybe the creator even did it. That's always possible too. Yeah. Is there any other... What's this? Tips and tricks? Destructuring task resources might help readability if a task takes multiple resources. Here's an example how to split up a resource. Because they have this shared block. Is that the split up resource? ABC right here. Your task, pass in ABC. ABC. You print it out. Destructuring syntax. Oh, okay. Oh, this is different. Bar shared resources. And all the shared goes into here. Huh. Void copies with when message passing. You're not there yet. Inspecting generated code. App is a procedurally macro that provides support code. If for some reason you need to inspect the code, you have two options. Inspect this file, or... Oh wait, no. There's no or. Arctic versus the world. Arctic aims for this. Minimal set of required mechanisms for safe sharing immutable resources. Comparison regarding safety and security. Comparing Arctic to RTOS is hard. A traditional RTOS typically comes with typical RTOS has no guarantees on system safety. There are claims to integrity, confidentiality, and availability. Regards only the kernel itself. An OS kernel, verified or not, does not automatically make a system secure. In fact, any system, no matter how secure, can be used in insecure ways. So they're just saying that Arctic is allegedly secure. Obviously, a traditional OS can guarantee neither confidentiality nor integrity, as both requires the security critical role to be trusted. Regarding availability, this typically boils down to the usage of system resources. Any OS that allows for dynamic allocation of resources relies on application correctly. Handles allocation/deallocations. Claims are correct. Security is completely out of the hands of OS. Okay, we don't need to read this. Got bored. Got bored because I get the gist. You can use channels in this. Really? Did that one quad project use? I don't think it did. Pretty sure it didn't. I'm not gonna look. I'm pretty sure it didn't. Don't forget to check the documentation of the hashtag app attribute listed under the re-exports section. Where are we? Is this all the same repo? Bare metal? Huh? All items. Oh boy. That's not all items. That doesn't seem right. App. Bruv. It said to come check here. It's gonna take me back to... Okay, so is it in here? Does it talk about it in here? What's this? This is something I'm familiar with. Arctic into the future. Talking about async and await API. Static allocations from modeling perspective. Await lists the run to completion requirements of SRP. Trio points. Improved ergonomics for async and await. A reoccurring use case is to have a task perform a sequence of requests and then await the results in order to progress. Without async/await, the programmer would be forced to split the task into individual subtasks and maintain some sort of state encoding. Okay, hold on. Did I just get brain blasted? Did I just get brain blasted right there? Have I been misdesigning my async functions because I wanted to force it to be synchronous? To be what I'm used to? Because every example I've seen designs it in this way where it does something and it waits. Consider your brain blasted. Yeah. My brain has been blasted. I think maybe the issue is more with using one library that was not async. And that one made the ergonomics weird, uncomfortable, non-typical. So they said improved ergonomics. Programmers splits it up normally. Essentially represents a state. The progression mechanism is built automatically for you at compile time by means of features. Huh. You know, it might just work. That might just work. The reality is, maybe async isn't bad. I just don't know how to use interrupts. I want interrupts, but I just don't know how to use them. My ignorance is making this more difficult. I have a different idea than how I'm supposed to implement it. Async await support still incomplete or under development. Nonetheless, Rust Async is production ready and covers most use cases. An important property is that features are composable, thus you can await either all or any combination of possible features, allowing, for example, timeouts or asynchronous errors to be properly handled. Arctic model. Arctic app is declarative and an executive system. Oh. Long live Chaos 8.
Oh, hi, Mark.
Twitch scam. That's number 2. Set a week ago. 6 Long Live Chaos Twitch scam followed me. Long Live Chaos 8 Twitch scam. Thanks for the follow, because that's definitely not a scam. We got some bots following random channels. So I was reading this. You have a set of resources operated by a set of idle, init, hardware and software tasks. So this every single program is always going to have this structure. Then the init task runs before any other task, returning a source of resources. Tasks run preemptively based on their associated static priority. Idle has the lowest priority and can be used for background work or put the system to sleep. If we already read this, we might have. Hardware task, yep. At compile time, the task resource model is analyzed using SRP and executive code generated with the following outstanding properties. Guaranteed race time. Yeah, I read this. We read this. Delaying timeouts using monotonics. A convenient way to express minimal timing requirements is by delaying progression. This can be achieved by instantiating a monotonic timer. Let's look up the word monotonic. That should be singular, I'm guessing. Monotonic, varying in such a way that it either never decreases or never increases. It's always the same. That's what we want. Here, they implement a monotonic arctic timer. Initialize. They create this token. And then they start it. It's based off of the sys timer. The sys-tick timer. This one has 12 megahertz. Then they have a software task that awaits for this timer. Here's a complete example. Initialize this timer. And then they have some tasks that are delayed based on this timer. So this is a software-defined timer. This is something that's just in the C implementations on STM32 already. So this is good to have based on sys-tick. So the system clock. What's this? Rust's futures are composable. This makes it possible to select in between futures that have completed. Common use case is transactions with the associated timeout. In the examples shown below, we introduce a fake HAL device that performs some transaction. We have modeled the time that it takes based on the input parameter n as 350 milliseconds, 350 milliseconds plus n times 100 milliseconds. Select biased macro from the futures crate. It may look like this. Call HAL with short relative timing using selected bias. Call HAL with long relative timeout using selected bias. So select the bias macro. You have two values. You have a V and then a don't care, looks like. V, you're getting the fuse. I'll print. I'll return V. And then just tick. You're delaying for 200 milliseconds for fuse. This will finish first. Where's this one? This one's got a 1 second. 1 second. I'm not sure about the select bias macro. I'm guessing you choose which one's finished first. Maybe? Not sure. Assuming the HAL get will take 450 milliseconds to finish, a short timeout of 200 milliseconds will expire before HAL get can complete. This takes 450. 450 here. This one's only for 200 milliseconds, so this one should check it. Extending the timeout to 1 millisecond or 1 second would cause HAL get to complete first. Oh, these are two separate examples. Oh, I see. So select which one's ready first. Either delay or the fuse. The delay will always finish first because 200 milliseconds is less than 450 milliseconds. All right. Here's a different example using the timeout after blank. So current time is now. do this 3 times. 1000 milliseconds, so 1 second. You add to the instant, and then you delay until 1 second has passed. This one's absolute point in time without drift. Absolute point in time for timeout. Without drift versus timeout. Timeout, you do 500 milliseconds plus 1 second. So this is 150. 1.5 seconds is timeout. So now is this time. Timeout is 1.5 seconds. They're doing a match, so a switch case. But they're saying once this function is ready, timeout at, you return timeout how get n. N comes inside this match. If it's okay, then you pass in v, which is whatever you define as a return here. V comes into here. It says tick now. You pass, you say when you returned. Otherwise, if it's not okay, then there's a timeout. Case where you want exact control over time without drift, we can use exact points in time using instant, spans of time using duration, operation. See, this is the thing. These are both keywords that are in the embassy library. They don't work the same, I feel. If I go to the embassy time repo, they have an instant, they have a duration. Instant is relative to system boot, so it should be the same. Maybe it is. Maybe it is. Duration represents the duration of a span of time. Implement the map operations you need. I haven't written any code. I don't know how I feel about it. Not sure how I feel about it. Let's go and look up Arctic examples. Oh shoot, misspelled. Examples. Arctic by examples is what we were reading. Awesome Arctic examples. This is in the same page. YouTube channel. Here's a development page from this one guy. He's using Arctic. This 2.0, I wonder. It might be. Oh, this is an example we were reading earlier. Oh yeah, and I saw our timer expired. Idle task. Okay, it's slightly different. I do have a timer. Here's a page from University of 12 students. Is that what that said? University of 12. Analysis. Benchmarks. So they did research. Okay. GPIO interrupt latency. Bare metal. Seems pretty thing. Bob Joe, welcome back. Thanks for the sub. Appreciate it. Yeah, I'm back streaming. I'm also really tired, but yeah, I'm back streaming. How you doing? Welcome back. Also, I'm not sure why the sub notification sound doesn't work anymore. It used to. Or maybe it never did. Maybe it's a different one. I know the follow one's working right now. I'll look into that. Yeah, I'm still in the Rust grind. We're 2 months in now. I think I started in February. That doesn't look that bad. This doesn't look that bad. Yeah, gosh, I don't even know if I can read this right now. Well, this is cool. They made a camera gimbal. Dang, look at this entire white page. What do they got here? They got a PID controller? Shoot, this is right up my alley. What do we got here? They got a pan and tilt, camera pan and tilt system. That's cool. Wait, is this MATLAB? Or not MATLAB? Simulink? This is just a graph, actually. Never mind. So they have a pan controller. Let me just change that up. A pan controller that they hold. Sample 10 kilohertz to get some data. They, at the 10 kilohertz, see what the current pan is. Current position of the pan, probably. Z hold. Oh, interesting. Am I interpreting this correctly? The Raspberry Pi is controlling how to control it. I guess this makes sense. It's probably like a GUI or something that's talking to over this Ethernet port. It's probably like, yeah, some GUI. Send data over the GUI through SPI to the STM32, which then converts that into microcontroller, or sorry, PWM values or something for that. What do we got here? What is this? Oh, they compared it to C++ code. Oh man, I wish I wasn't skimming this so much. There's actually a legit study, a legit research page. Oh, they talk about Rust. Ooh, I mean Ross, but ooh, there's a Rust library that's huge. Ross is huge for robotics. Not sure if anybody's ever. Dang, I also just realized you've been subbed for 4 months, Bob Joe. I don't want to dox you. I know who you are, but 4 months? Dang, bro. Thank you. Appreciate the support. But yeah, this is legit. 6 months? Oh my goodness. I didn't even realize. Well, again, I appreciate it. Are you coming back? Will I be seeing you again soon? I don't even remember. Is it May? Be seeing you again in May? Or is it June? Maybe it's June. June. Okay. Sweet. I look forward to it. It's been some fun stuff. Yeah, you would. You definitely would. Yeah, you definitely would. I think. Now you got me second guessing. I'm pretty sure. It would just make more sense. Because like the whole thing of interns is, right? You find somebody that you like. And then you hire them after. So it wouldn't make sense that it'd go to a different team. But yeah. Oh, the projects have gotten pretty neat recently. Let's see. It would make sense that they didn't bring back the same. Yeah, exactly. I agree. I think... again, I don't want to dox, but another person, part of our team that's interning, will be returning as well. That I was mentoring. So I look forward to seeing him again too. 2 of the 3 on our team. I think we had 3 interns, yeah. Something like that. Well, this is a neat paper. I just don't have the brain capacity to read it. Not him. The other one. I'll say that. The one that was in the other room. Yeah. Yeah. I'm not sure what that guy's up to, but not him. This is a pretty simple example. He was def on, bro. What is def on? Wait, what do you mean by that? Def on, bro? Oh, on one. Yeah, that's a good way to put it. Yeah, he kind of was on one, yeah. Something else, that's all I have to say. A very bold personality. Yeah. Okay. Wait. Was this it? No, this is just their example. Oh, did they? Wait, hold on. Did they actually do bare metal development? Like no OS on the RPi? Oh, that's impressive. That's a much bigger task than just using the existing libraries and stuff. I've never ran an RPi just off of bare metal. I figured you'd put a Linux. It's a thing where Rust can just run without no OS on the Pi. Is that, well, yeah, that makes sense. That does make sense, right? You just compile it. It's just like C. I'm just surprised that somebody did it. Like, that means they wrote drivers for these other pieces of hardware. Like it says here, GPU firmware. Oh, maybe it's a pre-compiled thing that they just loaded on, actually. I'm seeing the bootloader, clocks. So this is your typical bare metal stuff. Then they have each of these hardware pieces, that initializing. Then they start the GPU. Oh, these are maybe different ways you can load the hardware or the firmware. Then they load the CPU kernel. And they power up the CPU, and then they jump to the kernel. Maybe this is just talking about how they boot it up normally. Let's just skim through it. This is further explaining this. You got a YouTube video? Okay, let's see what this is. Oh, low level.
The Raspberry Pi
is a classic channel. Yeah.
Cargo manager. You have the cargo file here and our main source code file. So if we do basic
so they compile for the ARM7
code. We'll do a first. Accessible, meaning the linker.
This is just raw code, no library.
Called, include the
panic handler. Yeah, that makes sense. Start location. Have you been watching this guy much at all? Because he's popped up a lot in my feed recently. No mangle. Kind of setting up the linker scripts. Yeah, this is kind of in the tutorial for the Rust. Oh, they're looking at the Broadcom data sheet. So then they probably, doing address setups. Yep. This is the extreme bare metal. Just remember this view, seeing this when you got to this section. Yeah. This video. Oh, okay. Maybe I did come across it. For more files. Oh, okay. So they didn't need to develop anything. That makes it a lot easier. You're able to just pull off binaries that they have uploaded on their website or their GitHub repo. That's pretty cool. That's actually really neat. And people are liking it a lot. Maybe that's I wonder if they got the idea off of this. What is this? Writing bare metal code in Rust. Application code. RTOS. Or support package. Or crate. BSP. Drivers. OWL. This is the pack, which is what I'm missing. But Embassy has it. Panic handlers. Embassy handles this, but I could avoid it. Minimal Cortex M startup and runtime. So this is just the other platform I see instead of the Pi. Oh, here's a Pi. Hold on, what's this? Build a kernel for the Pi. Oh, dang. Rebuilding a kernel and then what? Getting the binary of it and somehow putting it on? Oh yeah. Copying it into the boot folder. Damn. It truly was like a PhD or a master's probably. MSc, this seems like the M would be master's. This is a master's project in the Netherlands. Well, impressive. It's a wild tangent for sure, but impressive. I mean, shit. I think I just gotta try it. I think I just gotta try it. So maybe making a new project would be ideal. Well, since you haven't been here in a while, Bob Joe, just a quick little demo. We got our chess timer right here. It's this person's turn. They just finished making their move. Now this person needs to make their move. They made their move. Their turn's over. Now it's this person's turn. They need to make their move. And just go back and forth. It's a nice little chess game. But the problem is, look at this main loop. Look at this main loop. Look how gross that is. This is spaghetti code. Yeah, I agree. It is pretty gross. We don't like that. I wanted to make this into its own function because this is pretty much identical as this code. Like I could just make this into 2 functions or even just 1 function. And this whole loop would just be pretty much 3 lines. But I was having some issues dealing with global states in Rust. It doesn't like setting up a bunch of enumerations for constants of like a new game state, white turn state, black turn state, game over state. I was having issues trying to typecast it because this match keyword, this is essentially switch case of Rust. And I just wanted to say like, okay, for the case where our state is the white turn, you know, do something. But it doesn't like that our value use of enums. Yeah, no, I mean, from starting working there, I definitely learned how to implement some nice enums and also implement, well, shoot, layout code really, you know, a big project, how to organize the files and have the files import in a nice clean way, at least with some projects. And enumerations, that's huge. Like magic numbers go away. You use them pretty much as you can. They're super handy. But in Rust, I mean, I don't know how to typecast. I don't know how to compare it. You know, I created this here. Oh, like I'm used to when you initialize a variable in Rust, you do this kind of terminology. But you can't actually do this. This is not how you initialize enum in Rust. How you initialize a regular variable, like these, right? You got your name and then the data type and then the value. But for enum, it's not quite like that. Yeah, they are very nice. You can, and that's the thing, you can do something like this, hashtag rep, and C, represent this next code as C. I think you do struct, and then you just write C code or something like that. Like the compiler knows how to do that. So if I do int, I don't know, test. Oh wait, this is a struct. Let's do enum. No? I don't even remember off the top of my head what the syntax of enum is. You just do test, right? Test. Test A. Yes. Does that work? Type def enum. Type def enum. And semicolon. Expected the bang operator. Okay, maybe I'm misremembering. My point is, I think you can make it a little bit more nice. I don't know off the top of my head. Don't want to go into another tangent, I guess. Kind of just thinking what I could do here. How could I make this project, one, cleaner, but two, kind of like figure this out, like a good design direction, I would guess, like how to use Rust, you know, how do you professionally design it? Yeah, me too. I want a different file. It's only 100 lines of code. Yeah. Yes, yeah. Absolutely. Only the like tasks you're doing, or the, you know, blocks of code or sections of code, you know, USB, read USB, blink light. I would want to initialize this and something else. But the issue I'm having is as soon as you break it out into another function, it's really tough sharing the data around. Like, you can point and see, you can just pass by reference. You pass a pointer to a struct, and the compiler doesn't complain to you. But with Rust, it will complain to you because it's not safe. It's not a safe practice for memory safety. So I don't know. I was liking what I was seeing just a bit ago with this Arctic framework, where it essentially just had the global spot. Where did that go? Let me just look at an example here. Or yeah, here's one with an interrupt. That's not a good example. That's not a good example either. Okay. That one doesn't have shared. Here's shared. You have shared and local. So you have memory that is accessed but immediately deallocated when your function's over. So like the stack in C. In C, you jump to a function, you work on some stuff on the stack, and then by the end of the function, it deallocates it. Local would allow you to do something like that. You initialize some known variables at compile time to be put there. But shared is your global, essentially, your static variable that is just shared across all functions. All functions, or all tasks. And I think that's what I need to do. No, yeah, definitely not. You don't have to malloc anything. This is your allocation right here. You're allocating that there's going to be a shared. So a 32, you know, unsigned 32. It is poggers, I agree. It's very poggers. What if I... Okay, well, I already committed this. Am I in a different branch? No. This is bad practice. How do I do this? What's it? I think it's get reset to main or something. I think I need to look this up. We want to just, whatever's not on GitHub, we're just gonna go back. Reset. It's like hard reset. I always am looking at this. Here we go. Get reset. Get reset. Hard. Hard. Origin main. Okay, this is working. This is gross, but there's no added nonsense. This is a fully working piece of code. So what we're going to do is branch off of this. Gonna create a new branch. Actually, we did do git checkout -b. This is gonna be called Arctic. I added an extra apostrophe. Arctic implementation. Or how about this? -b implement Arctic. I can't spell. Let's try that again. You probably rename stuff, but I don't remember how to do that. Don't know the command anymore. We're gonna do go ahead and do a git checkout delete implement Arctic. Oh, this needs to be not git checkout, git branch. Okay, then we're gonna do git checkout -b implement. There we go. Arctic. Cool. Now we need to import this Arctic. Use Arctic. We need to look on the repository or registry, I should say. Arctic. Okay, Arctic 2.11. Look at that. We can run this command, cargo add Arctic to get this dependencies. Just pre-installed on my system. Which really, this looks like more... These are features, okay. Yeah, you choose which compiler to use, that makes sense. We want to do 2.11 in our cargo file, which is like our make file. Oh, dang, it already added, oops. It already added in when I said cargo add. That's nice. Okay, we're getting a compilation error. What's the error? Cannot compile, no backend feature. Well, that's not even our file. I'm not sure what that's about, but okay. Well, okay, if we did this, this should compile. This doesn't make sense. So if I did cargo build, am I getting an error? What is this? No backend feature. Oh, I have to choose. Yeah, that makes sense. In here, or in here, I need to say which feature I want to use, which in our case would be the compiler. Features. Now the real question is, where's the list of features so I can get the exact name? Because I know it's a thumb V8 or something like that. Probably, no, probably in this page. API reference is usually where I find it. At least that's where I see it with Embassy. What's this? No. I search features. Huh, no. Okay. If I search here, features. Features. Search for features. Partial features, false features, test critical. Thumb V7 backend. Okay, but this is like an implementation. I want the list of features. Did they not have it? Like, MSC does a much better job of their documentation, I'm seeing. How is anybody supposed to know what to use? Like, you know, how to compile it. Maybe I should look at this template. Maybe this will help me out. Here we go. Yep, this is it. Wait, was that's under config? Interesting. Oh, do they not have the 8? That doesn't make sense. No, hold on. It should have the 8. 8's my compiler. Well, I have this target. Maybe this is just not updated. Just updated 5 months ago. Okay, that's Thumb 8 was definitely out 5 months ago. Huh. It said they support all cores. Like Cortex cores. Well, how about this? We look at the cargo toml and see what's going on here. Oh, okay. Do I just need to pass in this global variable? What do we got here? Some settings based off your profile. If you pass in build, run, looks here. If you pass in test, it looks here. If you pass in release, it looks here. This is new to me, huh? Neat. Deformat, yeah. All right, well, let's try that. That wouldn't make sense though. REST backend, like that's a Arctic backend. Isn't that a Linux variable? $? Couldn't. No backend feature selected. I guess I could always search this on Google. This is not even, that wasn't even Arctic. I just realized these are just random projects with that. Okay. That's not helpful. Arctic. Actic. Oh, and this is activate the quick backend. Oh, okay, I see. Put the name in there. Oh, here we go. Oh, but which one I use? Thumb 8 base backend or main? Main. It says right here. Okay, we're good. That was just a temp placeholder. I now see. So I go thumb VAM main dash backend. Ooh. Okay, it's building. Rust Analyzer is building. We'd like to see that. Okay, so then if I go cargo build, this should work. Just tell me that I'm not using these, which is correct. I haven't been. Total time is unused. Really? That's weird, because total time is used right there. It's never read. Apparently it's never read, but I see it being... oh. What? Yeah, you're being written to and read to there. Unused aside. Does it have a suggestion on how to fix that? May it overwritten before being read? Value assigned to total time is never read. Value assigned. Oh, because 0? Oh, so maybe I just don't. Is that what they're saying? Like, just don't allocate it? I guess. Well, anyways, if I do a cargo build or run, this should flash it onto this chip. And reset it, yeah, and it still works. Yeah. Alright, cool. So if I bring in Arctic, this is gonna change how this works, kind of. We can go to an example, probably. Is that? Yeah, this is that. White paper. Just by example. Arctic example. What is this? Racy source maskings? Huh. Oh, interesting. That even had a hardware interrupt too. Yeah, it's right here. Well, that's neat. They never imported Arctic either. They just kept it on the outside. So, well, how about this? I go and get the bare minimum app, the minimal app. So, we need Arctic app. And apparently I can just use this. Maybe I'll do that instead. Oh no, Panic Probe handles that. Never mind. Panic Probe, yeah, that handles the panic handler already. Let me get into Arctic. Right? They're saying implement app. App. Yeah, this async task. Instead of main. Instead, we're going to off to the side up here, I guess. Put it below. Yeah, let's put it below. How about that? Put below. We're gonna make app. And just like it says, device equal. Oh, how do you know the device name though? I mean, I know STM32U575. Is it just gonna be this? That I don't know about. Oof, that copied weird. I wonder what that's about. How would it know what the pack is? Is the pack Arctic app? Okay, if I come in here, is it supposed to find that off of here? App. It takes... What am I looking for? App. App is a function. Okay. Token stream. Input and arguments. Attribute used to declare a Arctic application for user documentation. See here, I've already been there. Should never panic. Cargo feeds a path where it later converts to a string. Default build path is this. Traverse up to the first occurrence of target. Project working directory target. This, Arctic. And then the hash, so probably the build output. And then the project directory target. If no target directory is found, project directory output is used. But how would it know what the name is? That I'm trying to figure out. Well, in this file, this is probe RS's name. Config all. Target architecture, ARM, target OS. Expected items after attributes. Oh, that makes sense. Because I'm not actually writing anything yet. I don't know how they got this name. That I wish I did. Arctic. GitHub pages. Is this just for that same Arctic page? Yeah, thought so. We're getting started. Getting started. We did read about that. To here? What was I reading? It had like the step-by-step, like what you do. Begin. What is this? Use the app attribute. The attribute only applies to mod item containing the Arctic application. Wow. Yeah, this points back here, yeah. This must be a full path pointing to... Okay, add mandatory device argument. This is path, okay. So if we come into here and we do embassy, STM32, pack? No, not yet. Well, hold on now. How did I get the pack? I've seen it before. Oh, how do I get there? Is it not pack? Peripherals? Pack? Pack? No, it just keeps doing pack. How about do this then? Rust, embassy, pack. RP pack, RP pack, RP pack. Oof. This is an announcement. What's that one example? Man, this really sucks that I can't remember. Maybe he does it? He does not do it. But it did maybe spark. Oh, hold on. Pack GPIO. Okay, hold on. So this is the word pack? Can you just do that? Pack. Doesn't look like it. Oh, STM32 meta pack. Meta pack. Can you do that? odd. If I go to crates.io, what do I get here? STM32 meta pack. This exists. Whoa. Are you able to just import this? If so, my mind is blown. Oh my gosh, you might be able to. Holy crap. Okay. So say I do. Say I do import that. What then what? Then what? Where is it at? There we go. STM32 meta pack. Version 15. Oh, wow. Yeah, I thought for a second it was actually importing it correctly. So if we do use meta STM32 meta pack as pack, and I go here, how does it know which STM to use? That's the only thing that I'm curious about. Okay. Customized for each chip. This is huge. It's just handwritten. All the registers. It does seem to be nice, but I haven't contributed anything. So I feel like I'm a phony. I feel like I'm just taking. I take. Not giving back. It's cruel. But I would like to know how I could make this work together. I remember reading through this at one point and trying to contribute, but I was like, yeah, it's gonna take forever. Right, I know. It's a big question. Where do you begin? The main thing that I've seen is that on these pages, they'll have this issues tab. And these are people complaining about a bug or a feature that they want. Sometimes there's a label that's like good first issue. Yep, that says good for newcomers. Of course, it's not on this repo, but you'd look for that usually. And you click on that, and then you'd see if the repo has a like guide on how to contribute. So this one's a whole guide on how to do it for that repo, if it's a good repo. Now, I've never done it. I've tried before. I had issues building though. Like building the environment. It was not fully building it. I was like, do I want to be debugging this build system right now? Not really. I want to write code. And well, I just kind of gave up on that because I can work past and do my actual project without doing that. But yeah, I think contributing an open source project does add a nice little stamp on your resume. I think it's pretty, sets you apart from a majority of people, at least straight out of college. Okay, that can be part of it, yeah. But like the build system itself, this is not even like me changing code yet. This is me, at least in my case, I was downloading the repo and then, cloning the repo and installing the tools they said, and then just trying to build from source. And I don't have generally an enjoyable experience building from source, just from work and, you know, past projects I've done. It's kind of always gonna have some issues at the beginning. I'm just lazy. My free time, I'm like, ugh, do I really want to be debugging tool dependencies? I don't know. That's really just a me problem, but it's okay. I'd rather, I guess, make a project and have people work on it with me. That'd be sick. That'd be a little better. Because ideally you'd make it in a Docker container. Like the dependencies are in a Docker container, so you don't need to install them separately or whatever. I think that's the way it should be done. But an example repos that I was looking through, they don't do that. It's a shame. Okay, well, I'm looking at this. This embassy, right? Apparently it just knows. Apparently it just knows already. If you're in this embassy, well, you're not even in embassy. You're not even importing embassy. You're just grabbing the raw registers. Trust me, bro. Super spooky when they say trust me, bro. Just trust me on this. Yeah, that's valid. It's hard to trust people. It really is. What if I try to import it and build it without using it? How can I trust you? How does this work? Yeah, I mean, this page, this code, I don't know. Yeah, for all you know, I just off to the side wrote this in Arduino, and when I hit the run, I just have this actually just sniffing on the serial lines, you know, and getting a trigger to actually do this. I've never actually coded in Rust. Rust has just a made up imagination. This is just Photoshop. This is a set. You've been punked. Okay, here we go. This one's giving me something. It panicked. No cargo feature enable. Oh, let me guess. I just got to go into here. Not here, but when I import it, I just set the feature. Is that it? Okay, so that's not bad. I go into here. Oops. Let's go 17. Insert. This is an interesting music choice by the random algorithm. Listening to Mexican or Latin American music. Or I should say Central American music. And then this is probably the name of our chip, but the thing is I don't fully know. I don't know if they have an example of it. This sure as heck doesn't have it. What about the documentation, maybe? No. No, it doesn't have it. Ugh. How are you supposed to figure that out? Like, how would it know? How would a developer know what to import? If I go into here, this is the feature. I guess this is how you're supposed to know. Pack, environment, pack path. Okay. So if I come over to this, source, chips, then you find your chip. Probably, hopefully, perchance. You go all the way down to U75ZI. And then what? Pack. Use your hashtag define file. So do I just say, I'm not sure. Actually, I don't actually know. This is a feature pack. Well, or let's try a different one that's feature. So if I go to Arctic and then I search for the word feature, Cortex M is a feature. Only one. Cortex M. Okay. Didn't quite work for that one. If I, is there features in this one? Cortex M has features. Is that in here? Nope. How about, I mean, STM32 definitely is in here. If I search for features, features flags, features label. 19. Document features. Feature time driver. Okay. Feature external interrupt. Okay. Feature low power. Okay. So you would type in that. It's like a hashtag define unstable pack. So why didn't I just say pack? Isn't that already importing it? Why would I need to manually do it? You know? To me, I guess it's just not public. Maybe that's the problem. I feel like this would allow you, it says public though. You should be able to define STM32 meta pack. I'll go build first. Maybe that's it. And could I do? Let's try something random like pack. And these are all addressed as something. If I did like pack and then interrupt, I guess. Interrupt public. Yeah, interrupt public. Interrupt. This autocorrect is not going to let me see it though. Interesting. So I would have thought I could just do that. So then I can come down to here and say app pack. And that's how they're doing it. They just call pack. Okay. Dispatchers. Those seem like the interrupts. I'm looking for that example. I'm not finding it. Oh, good. Another follow from Long Live Chaos 9 Twitch scam. We got 3 bot accounts. Somebody's bot account following over and over again. Amazing. Whose college project is that? I am lost in the sauce of trying to find where this was. Embassy? Yeah, I think it was, because I was trying to find examples, so maybe it's over here. Let's not remove that page. Yeah, maybe it was one of these. It could also be something else too. Oh, wow. This whole time it says Embassy ST. I didn't even realize there's an Embassy example right here this whole time. This is huge. To me, at least. This is humongous what? So theoretically, I just copy this, I think. And yeah, for the device, they just said pack. So if I came in here and just straight up like copied this, put it here. Wonder what would happen. Doesn't know what pack is. Okay, so we do need pack. Which we... What if we did... CSTM. Embassy... STM32 pack. Mechanic is ambiguous. Let's comment this out real quick. All of that. Big old comment. Big humongous comment. So I'm getting complaints. This is a name from a global import in outer scope during import of macro. Where's this getting panicked? I don't even see that word. I don't see that word anywhere. I mean, panic probe. Maybe that's what I need to do. Oh, no, I already do that. This is literally the exact same. I might need to do this, though. Oh, yeah, I definitely need to do that, actually. Comments. Actually, we can keep that how it is. Oh, no. Then change it. Okay, huh. Hmm. I mean, I don't have these. That's possible. This is a failure. The docs weren't able to build. They still pushed it to main. That's crazy. They still pushed it to main even though it was failing its pull request checks. Huh. Dependencies are tick. Stable pack. Do I need unstable pack? Ooh, didn't like that one bit. I hated that actually. Oh, because I already, one, I already declared it, and two, I misspelled it. So I can see why I didn't like that. Panic probe 3 print DFMT. I think that's what mine is too. DFMT. Oh, wait, no. Panic probe 3.1. It's just a printing. Single section, single core, yeah. Huh. It really doesn't like that. Granted, I don't necessarily want all this other stuff. I just wanted a basic example. So if I got rid of dispatchers, I also don't know what peripherals is about. Let's get rid of peripherals. If it just said pack. Could not find peripherals in pack. Okay. Right, so then what if I do this? Panic is ambiguous. Ambiguous because the conflict between a name from a global import and outer scope during import or macro resolution considered adding an explicit import of panic to disambiguate or use self-panic to refer to this macro unambiguously. Super. What the heck? Consider adding an explicit import of panic to disambiguate. The error originates in the attribute macro app nightly builds run with not negative. The macro backtrace. How about this? Oh, about this. I go to here, and where did that code go? Did I delete? No, it's here. Source, Blinky, RS. We hit him with the old copper pasta, right? Just see how this reacts. Okay. So this is all old code. And now we paste in our new code. See where it's failing. So Arctic monotonics. Doesn't know where to get that. Makes sense. We don't have it in our dependencies. So let's add it. Arctic monotonics on monotonics. I'm going to do 1.0.0. Figure out what the actual one is now. Cargo. Or actually, you know what? We could just go into here. See the exact ones they're using. Oh, no, we can't. That's right. Because they were referencing it locally. Arctic. Arctic monotonics. Dash mono. Monotonic or monotonics. A library that provides implementations of monotonic trait. Why is there a different one. Okay, I'm gonna assume it's just this main one. Yeah, that's the main one. Is this other one also by M? It is. Kind of confusing, but all right. Oh no. Okay. Kind of guessed it first try, but no S. Monotonic. Oh shoot, did that fix everything? Or it's rebuilding. No, it didn't fix everything, but it... Oh, this one uses monotonics. Okay. Enough? Cystic. Unresolved import. Could not find cystic. Great. Cortex M cystic is right here. So maybe I need to import it. Feature. Version is equal to this. Features is equal to whatever that was. Cortex M cystic. Cortex dash M dash sys tick. Okay, looks like that part worked. Getting an error somewhere else. Output. Struct has 0 generic arguments. Maybe the version of embassy. Yeah, that's kind of weird. That should be working. Move this generic argument. Expected 0. When was that made? When was this example made? That could be an old convention. 2 months ago. That's pretty recent, not gonna lie. Pretty recent. But if I recall what the output... I think it has a function? Yeah, that's not normal. Usually it's just static by itself. Why may you do PC6? If you do PC6, is that... No, it's not doing anything. So what if I just do static? That, like it says. Does that work? That built. If I run. What even is it supposed to do? Blink an LED? I mean, something's... It's executing something every... That's definitely not 1 second, I tell you that. This is delays for 100 or 1,000 milliseconds, which is 1 second. But 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Yeah, like maybe 10. Hold on. Let's wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, I don't know. This blink is doing it on its own. It's asynchronous blink. They are counting it off of the system clock. Hello world. Output. Uh, This is just staying in the task. It never goes into an idle task. It doesn't have an idle task. Okay. What are they doing? They're creating a token for monotonics. We're starting it at this rate, 25 megahertz. And they are initializing it. This is the embassy way. Calling it output. Okay, embassy way. Setting it high, embassy way. Spawn LED. So, blink. Spawn. That's interesting. That's an interesting way of doing it. You're calling this function and spawning it. Because how? Because it's context? What is LED? LED is this. Is this a self? We call it self, probably. I don't know, spawn. Is there a spawn keyword up here? No. Just notes. Also, why is it using an SPI if SPI is never referenced? What the heck does SPI have to do with anything? If I search for SPI1, it's only there. Why is it even there? What's dispatchers mean? If I go to the app. Oh, that's super. Oh, interesting. If I go to app. Inputs. I do feature. Feature. Yeah, it's all the same. Huh. Not too sure about that one. I also don't have the right LED. Where's my LED? We need the data sheet really quick. Figure out what the LED is on this board. LED. LD5, which does not tell me the actual name. PC7. Ario run. Okay, here's our LED. A little hard to see, it just turned off. Supposed to be blinking every second, but our clock, our internal clock is very, very inaccurate. Yeah, it's a little tough to see if I go full screen on that one. Okay, look over there. Green. Apparently after 1 second this goes off. That's definitely more than a second though. Yeah, that's funny. Not sure. 1000 milliseconds. Huh. Crazy. they spawn a task here? Let's look at the... This is the only example they have of that. We looked at this, for example. How did they spawn a new task? That's system start blink spawn. Wow, okay. That's how they did it there. What about for the real-time clock? They have any? No, these are both hardware. Yeah, those are both hardware, no software defined task. Okay, what can we do, like a little bit of both? The example of both? Is it just exactly what I would think? Just need confirmation. So here's an asynchronous task. Heartbeat spawn, okay. So that's how they did it there. They don't have hardware. I'm going to assume it's the same. This is wild. Alright, well let's do some big picture thinking here. Is this the path forward? Should I do it this way? In terms of setting up the interrupt, it's still the same. I'll need to do it using the registers, using the pack, right, the PIC. Initialize assistic interrupt. They did that? Oh no, this did that. This did that behind the scenes. Assistic, yeah, this doesn't get imported or anything. I click here. Assistic. Oh, it takes an interrupt. We passed in an interrupt apparently. This is an interrupt, allegedly. This macro takes something. Yeah, that's neat. But okay, yeah. Yeah, we'll need to do the interrupts the way that it's intended. Our issues of the game state though get solved because now we have this shared and local. Just gotta be careful on how I access it. But I think I can maybe get more steam or more progress implementing it this way, using real time and embassy just for the how, and maybe some of the, oh okay, specifically we're gonna need it for the pack. There's no way around that. It's the only way we can get the pack. It's the only one that exists. But the how, it's handy. It's handy if you're doing initialization. Maybe not. I mean, if you're already creating it, I guess you're kind of forced to do it. But this is a cool proof of concept that you can use both at the same time. I think I'd like to do it. Let's see if I get rid of SPI1. What's that do? What's that do? That still build? Cargo build? Yeah. Why was it even there to begin with? That doesn't make sense. Okay. Huh. Yeah, that's interesting. Well then. I think I'm gonna call it there for tonight. It's kind of a researchy night, not really much progress in terms of deep coding ideas, but a lot of research about Arctic. Looks promising. Thursday I won't be streaming. I will be snowboarding somewhere, which will be a lot of fun. But next week, next Tuesday, plan to pick up from here. And I may have a different board by then. I have 3 boards coming in. If I do, I may change to that board. It's still STM, but it is a new board. Oh wait, no, I can't change it that board. It's too new. No HAL has been made for it. had to do it by hand. H7 could do it. Yeah, I don't know how to think about that. But anyways, thanks for listening to me just ramble on and say nonsensical things. Appreciate the audience. Hope y'all have a good night, and